Hello everyone, myself Geeta. In this video, we are going to work out the problems based on substitution method. Already we have seen few on one type of problem under substitution. Now we would be mixing up all the types together and we would be working it out. So let's start with this particular problem. First one, integral 2x divided by 1 plus x squared dx. Whenever you look into the problem, first you have a check with your denominator. What is the pattern of the denominator? Okay. If you consider your denominator as one of the function, and when you differentiate that, if you're getting a numerator, then it is very simple to solve. What I'm actually saying is, if I have my denominator as f of x, this is going to be my denominator. And then if your numerator is the differentiation of your function, which you find in the denominator. So whenever you are having it in this pattern, integral f of x, and then in numerator, if you have f dash of x dx, then it is going to be equal to ln of that particular function plus c. Always, it is true. So for example, in this particular problem, let's observe. So I have here, if you observe here, the denominator is 1 plus x squared. When I differentiate my denominator, I get 2x. That's nothing but my numerator. In that case, I would be getting my answer as ln of 1 plus x squared plus c. That's it. The answer is done. So that's how you need to have a check with your problem. Whenever you are being given with a problem, observe the denominator and the numerator. And for your denominator, if you have the differentiation in your numerator, in that case, it's easy. Like we can just put with ln of that particular function plus c. That's going to be my answer. So for this question, since I have my denominator is going to be my function, which is equal to 1 plus x squared. And I observe my numerator is 2x, which is nothing but f dash of x of my function. Then my answer is going to be ln of, so this is going to be, I'm considering it as I is equal to, then I is equal to ln of 1 plus x squared plus c. That's it. It got over. Now let's move on with the next question. See, whenever you're doing a substitution problem, you need to have a check one more thing. You need to look for one when you differentiate of whether numerator or denominator. It's up to you. Like when I differentiate a part of a question, I need to get the remaining part of my question. That is what we go. That is how we do it in substitution. What should I differentiate? So what you would be looking is, what should I differentiate? What should I differentiate to get the remaining part of my question? So this is how we would be looking into whenever we are handling substitution problem question. So here, let me consider this as I is equal to. So now, what should I differentiate so that I get the remaining part of my question? See here, I have log x. When I differentiate log x, what I would be getting? 1 by x dx. So you might think, why didn't she choose 1 by x? When I take 1 by x, when I differentiate, I'm not getting log x. I need to get in that pattern so that I would be easily go ahead and substitute and I would be able to integrate. So let's have a check here. Let log x be equal to t. So when I differentiate log x, I would be getting 1 by x. I'm differentiating it with respect to x. So that's the reason I'm getting in this way. Now this dx which is here, when it goes to the other side, I would be getting 1 by x multiplied by dx is going to be equal to dt. That's it. Now let's go with our substitution. I is equal to. Now log x I substituted as t, it became t square. Now dx by x is nothing but dt. Now let's integrate t square dt, which is going to be t cube by 3 plus c. So in that case, now what is my t actually? In what, from where, like, what did you substitute for t? Log x. So I will go ahead and replace t by log x, the whole cube by 3 plus c. That's it. Problem done. So now let's move on with the next question. Third question. So whenever you're facing something with a substitution type of problem, how will you identify it's a substitution of a type of problem? When I'm taking a part of my question, when I'm differentiating it, I should get the other part of my question. This is what we would be looking into. Now, in this question, I don't have a numerator separately or denominator separately. Like I have two terms in my denominator. That's where the check is. What I need to do is, let me consider this as I is equal to. I need to take something common. If I take x common, I would be getting it as 1 plus log x dx. Now, which one I should differentiate in order to get the remaining part of the question? If I go with 1 by x, when I differentiate, I'm not getting 1 plus log x. That's not helping me at all. But if I take 1 plus log x, and when I differentiate 1 plus log x, I get 1 by x, right? So that is one part of my question. It works. So my substitution is going to be let 1 plus log x be equal to t. Then when I differentiate, I would be getting 1 by x because I'm differentiating with respect to x, dt by dx. And this dx goes to the other side. 1 by x dx is equal to dt. Now, the entire I which is there in x would be getting changed completely to t now. See here, I is going to be equal to 1 by t, and then I have dt because dx by x is nothing but dt. So done. So now what is the, going, like when we are going to integrate 1 by t dt, I would be getting ln of mod t plus c. What is t actually? T is nothing but 1 plus log x plus c. That's it. It's been done. So now, like if you are unable to think in the way, as I told just now, like which one I need to differentiate to get the other part of the question, if you're not able to think it that way, see something which is getting preserved within the bracket. For example, in the beginning it was not, but when I took something common, this part of my question got preserved. So that would work as a substitution. Mostly 99% it works. The problems, whatever I have solved till now, whatever I have faced it. Based on that, I tried. Mostly it works, and you can also give a try with that. But if it didn't, we have to search for the other way one. We have to think in other way one. So now here, for example, the log x, which is there within the bracket here, when I consider that as t, it works. So now let's go on with the fourth one. So now here in this particular problem, we have with the sine and cos. Now let's see how to solve this particular problem. Now let's see which one I need to go for substitution. Now if I take sine x and I differentiate it, I get it as a cos x. But cos x is not a normal function for me here in my integrand. Actually, it is sine of cos x, right? So that is there. So I may not be able to, like, it's not an easy way for solving. It's not, it can't be solved in that way. So now what I would be taking, what I told, something which is getting preserved, which is getting preserved here. Obviously, cos, a composition of a function. Mostly in those cases and all the bracket which is there within the bracket, it always works. So now let me consider. Let cos x be equal to t. Now when I go ahead and differentiate cos x, I would be getting it as minus sin x. When differentiating with respect to x, I would be getting something like this. So in that case, minus sin x dx is going to be equal to dt. Great. Now, if you just observe here, you have sin x here, you have dx here. So this part of the problem is solved, but you have a negative which is not there. That means I would be getting a negative sign there. Okay. That means my sin x dx is going to be equal to minus dt. That's how we would be doing. Now let's start solving this particular problem now. Let's complete it. Now here I is equal to, I would be having sine of t. Cos x is getting replaced by so sine of t. And then sine x dx is getting replaced by minus dt. Right? So this minus, I'm taking it out. And then I have integral sine t dt. So now, the integration of sine t, we are aware, it is nothing but minus cos t plus c. Okay, great. Now minus minus becomes plus and I would be having cos t plus c. What's the t? Replace it back. So t is gonna be cos of cos x plus c. That's it. Simple. Done with our substitution with the fourth one. We will go with the next one. So now we have something, the one which we already did this particular method in the previous video. If you're not done with that, kindly go ahead and check those problems based on substitution which I've done. The problem is very simple. See, we have the product of sine and cos. We are aware about one particular formula with sine and cos. Whenever I have sine 2 theta, it is going to be equal to 2 sine theta cos theta. And when you observe, this part is there as my question. What is missing is 2. So let me introduce that. So what we would be doing, multiplying and divide, multiply and divide by 2. So in that case, I would be getting 1 by 2 integral 2 times sine ax plus b cos ax plus b dx. Great. Now, what is this equal to? 2 times of sine theta cos theta is equal to sine 2 theta. Then in that case, I would be having integral sine of 2 times ax plus b dx. That's it. Now, after this, I would be going ahead with my integration directly. So now let's integrate. So now here, what I told you, whenever you have integral sine of ax plus b, in that case, we would be getting minus cos of ax plus b divided by a. This is how we would be having whenever we are getting it in a linear format. The same way here also I would be getting. So now here what would happen? I'm not having just ax plus b. I'm having 2 times ax plus b. That means I would be dividing it by not only a but also 2. So here I would be having 1 by 2 integral, sorry, no need to, I will just integrate. So it's gonna be sine integration is gonna be minus cos. So minus cos of 2 times ax plus b divided by 2a plus c. That's it. Over. So this is gonna be minus 1 divided by 4a cos of 2 times ax plus b, then plus c. So that's it, done with my integration for this particular problem. Now suppose if you're not getting an idea of trigonometric identity, what if that is not striking your mind, like sine 2 theta is equal to 2 sine theta cos theta, I'm unable to apply this particular identity. Very simple. I told you something which is getting preserved within the bracket, but there, because when you see this ax plus b, you may not be able to recall that particular formula. Just for this, if you are able to see it in this format, you might be able to. So if that's the reason, you can go with substitution. What you would be doing is, let ax plus b is equal to t. In that case, a is equal to dt divided by dx when I'm differentiating it with respect to x. Okay, when I'm differentiating this one with respect to x. Now a dx is equal to dt. Now, see here, the problem here, it gets converted to integral sine t cos t and then dt by a. So 1 by a would be out. Now you just have a check. It is of the same pattern of this one. Now you would be able to recall, since you had ax plus b, it sometimes for few people you might find it difficult to recall that. So that time the substitution method helps them. So you can solve it in that way. Now let's move on with the next one. Next one also is very similar way. So here, instead of doing it using the direct way, which I've already taught you in the previous video, I'm going to do it using the substitution method. So let's see how this works. I'm going to consider it as I is equal to. Now what I told, which is getting preserved, look for that. So now which one of it is getting preserved here is this one. See, I don't have a bracket as I used earlier, but you have square root, and in that you have term. Inside the square root, whatever is there, you go for substitution. Always it works. So now here, let ax plus b is equal to t. Then I would be having a is equal to dt by dx. So a dx is going to be equal to dt, and dx is getting replaced by dt divided by a. Now let's see how our I is getting changed. I would be having root t dt divided by a. 1 by a is a constant. Integrate root t dt. So when I integrate t to the power half dt, I would be getting 1 by a t to the power 1 by 2 plus 1 is 3 by 2 divided by 1 by 2 plus 1, which is 3 by 2 again, plus c. So now here I would be having 1 by a, and here 3 by 2 which is there. 2 lies in denominator, that means it's gonna become a numerator, into 2 by 3. I would be getting t to the power 3 by 2 plus c. So now what exactly is our t? Let's replace it back. Let's replace it back. Let me add some space. So here I would be having 2 by 3a. T is nothing but ax plus b whole to the power 3 by 2 plus c. That's it. Right? This problem can be done directly as well. Suppose I have here, now let me just erase this part and show it to you how to do it in a direct way. So here I will use a different color to show this particular workout. So I have I is equal to integral root of ax plus b dx. So now it's in the linear format, the inside one which you have. So it is nothing but integral ax plus b whole to the power 1 by 2 dx. So now in this case, we can do it directly like ax plus b whole to the power 3 by 2 divided by 3 by 2 into a, right? So in that case, because it's in linear format, we have already discussed about this formula. It's going to be 2 by 3a into ax plus b whole to the power 3 by 2 plus c. Don't forget plus c. That's it. We got the same answer. But this was a faster approach. It can be done directly. Even we would be skipping this step, we would be writing this directly. So it's a 2 mark, we can get it just like that instead of working out this much. So try not to waste your time and try to apply the shortcuts whichever is wherever it is possible. So now let's move on with the next question. So here I have something of this particular format. I have integral x root of x plus 2. Okay, root of x plus 2 dx. Now, which one should I substitute so that I would be getting a remaining part of my question? So here, the remaining part of a question is a little bit troublesome. But as I told, the one which is there inside the square root, go for substitution with that. It would help you out. So here we would be doing the same thing. Now, what we would be considering is let x plus 2 be equal to t. In that case, I would be having, when I differentiate both the sides with respect to x, I would be getting dx is equal to dt. So actually, you would be getting 1 is equal to dt by dx. And this dx goes to the other side, so I'm writing it dx is equal to dt. So you got dx is equal to dt. And now let's go back to the question. Now I'm considering this as I is equal to. Now I is equal to, so this root of x plus 2 became root t and dx became dt. But what about the x which we have? I may not be able to write it as x. I need to convert everything to t. So here we have a solution for that. If x plus 2 is equal to t, then x is equal to t minus 2, right? So that is what we would be writing t minus 2 here in the place of x. Now, what would happen? This root t would be getting multiplied with both the terms. I would be getting t to the power 3 by 2 and then minus dt minus 2 times integral t to the power 1 by 2 dt. This is how I would be getting. Now, after this, let's go ahead and integrate it. So when I integrate t to the power 3 by 2, I would be getting t to the power 5 by 2. That is 3 by 2 plus 1 divided by 3 by 2 plus 1, which is 5 by 2. And then minus 2 times t to the power 1 by 2 plus 1 is 3 by 2. And here also 3 by 2. And then I would be getting plus c, right? So now the 2 which is there in the first term, if you observe here, that is in denominator, so it becomes the numerator. I would be getting it as 2 by 5 t to the power 5 by 2. And then again here in the denominator, if you observe, that becomes the numerator 4 by 3 t to the power 3 by 2 plus c. So now here, what is the t actually? Just replace it back, then the problem gets over. T is nothing but x plus 2 whole to the power 5 by 2 minus 4 by 3 into x plus 2 whole to the power 3 by 2 plus c. That's it. It's been solved. It's very simple. It's just you need to just make a decision which one is going to be your substitution. Let's start with the next one. So now here, after this particular problem, here also the one which is there inside the square root, obviously, every time it works, you can have a try with that. So what we are going to do is let 1 plus 2x square, let it be t. Then in that case, when I differentiate both the side with respect to x, 1 becomes 0, and here I would be getting it as 4x is equal to dt by dx. So this dx will go to the other side. I would be getting 4x dx is equal to dt. But if you just observe the problem, I have x and dx in my question. I have x and then I have dx in my question. X is there, dx is there. But I don't have 4 there. So in that case, How I would be doing a change is x dx is equal to dt by 4. This is how we would be doing. Now let's come back to our substitution procedure. So now here I have root t dt divided by 4. So 1 by 4 is a constant which comes out, and I would be integrating root t dt. And we know very well when we integrate t to the power 1 by 2 or root t, I would be getting t to the power 3 by 2 divided by 3 by 2, which is nothing but 1 by 2 plus 1. That's what we have done with the power as well as with the denominator. So in this way, I would be getting and then plus c. So now what would happen here is this 2 which is there, 3 by 2 is there, and this 2 which is there in the denominator, it comes to the numerator. I would be having 2 by 4 into 3, t to the power 3 by 2 plus c. So now, so what we would be doing here is cancellation. So I would be getting 1 by 6. T, what's the t? Let me just substitute it. 1 plus 2x squared whole to the power 3 by 2 plus c. That's it, done. So I hope you guys are able to understand, and I'm making it simple for you. Now let's work out two more problems and end this video, and then we will go with few more substitution problems. Around 40 are planned to do. Let's have it. Let's give a try with all the 40 problems. Okay, now let's come back to this one. Now here, which one you would be substituting? Obviously, which is there inside the square root. Always that works. Now here, let x squared plus x plus 1. See, what I told previously, the same thing applies here also. Which one, when I differentiate, I get the other part of my question. That works always. Okay. So now if I consider this to be equal to t, then when I differentiate both the side with respect to x, I get 2x plus 1 is equal to dt divided by dx. Okay, now your mind would be saying that I don't have anything 2x plus 1. So it is there, but it is hidden. So now let me just rewrite this for you. This is nothing but 2 times, so let me take 2 common, 2x plus 1 into root of x squared plus x plus 1 dx. Now, did you observe? You are having that part as which is available pretty well there. So now here 2x plus 1 dx is going to be equal to dt. Now let's replace everything with t's, and I would be getting 2 times root t and then dt. That's it. Now root t, when I integrate, I would be getting t to the power 3 by 2 divided by 3 by 2, and 2 is there already out. 3 by 2 divided by 3 by 2 plus c. So what's my t? That also we would be applying it. This 2 which is there in denominator will come to the numerator, and this it gets multiplied with another 2. It becomes 4, and I would be having 4 by 3. I'm having 4 by 3. And then t, what exactly is t? Let me just replace that also. X squared plus x plus 1 whole to the power 3 by 2, and then plus c. Done. So we have solved this one. I think you guys are also finding it easy. The stress would be relieved, like when you start knowing how to do the problem. So I hope that has been relieved. Now let's do the final one in this video. So now here I have something called integral 1 divided by x minus root x dx. How to solve this one? My first approach would be taking out common because I have two terms and I do have something common there. So let me take it out. Then only I would be able to know which one to substitute so that whether I'm getting the other part of my question or not. So let's have a check. When I take something common here, obviously I would be taking root x common, and here I have root x minus 1. How did it work? See, when I have root 4, it is 2 because it's getting multiplied 2 into 2 and I get 2. Okay, plus or minus 2, obviously we do that. I'm taking positive here. And now here it is not that. I have just 2 here. So this 2 is nothing but root 2 into root 2. Then only I would be getting it as 2. So same way, when I have an x, it is nothing but root x multiplied by root x. That's the reason I'm taking root x common. So that means here I have root x into root x minus root x in this problem. So now you observe we have something common and I'm taking root x common. I get root x minus 1. So that's how we got it, dx. Okay, now here which one should I go for substitution? Obviously, I would be going with root x minus 1 because when I differentiate root x, okay, that is x to the power 1 by 2, I would be getting 1 by 2 into x to the power minus 1 by 2. So which is nothing but 1 divided by 1 by, oh, so 1 by root x. So what other part of my question is available? So now let's go with the substitution. Let root x minus 1 be equal to t. So when I differentiate this both the side with respect to x, I would be getting 1 by 2. See here, x to the power 1 by 2 is going to be my y. Then in that case, my dy by dx is going to be equal to 1 by 2 into x to the power 1 by 2 minus 1, which is 1 by 2 root x. So that's the same thing which is happening here. So I would be having 1 by 2 root x dx is equal to dt. Okay, done. So now this part, I don't have 1 by 2. So that's the reason I would be writing it as dx divided by root x is going to be equal to 2 times dt. Now let's go ahead with our substitution. I would be having dx by root x is getting replaced by 2 dt divided by t. So 2 would be coming out. I have dt divided by t. And we know which part of our integration integration formula we would be using. So here I would be getting ln of mod t plus c. So it's going to be 2 times ln of, what is the t actually? T is nothing but root x minus 1 plus c. So with this, the problem gets over. This is how we would be solving it. So in the next video, we will solve 10 more problems under substitution method. Thank you guys.